Okay, in this next example, we have a case where deep sea divers must wear headlamps when the amount of light available is 50% of that you would find at the surface. Obviously, the deeper down you dive, the darker the water gets. And they're saying that they lose approximately 2.2% of light every meter that you descend below the surface of the water. So basically, the question's asking how far down are you allowed to dive before you have to wear a headlamp? In other words, how far down can you dive until there's 50% the light that would normally be available at the surface of the water? So we'll let D represent the depth in meters, and since you're losing 2.2% of light each meter you descend, you're technically retaining 100 minus 2.2, or 97.8% of the light. So in other words, you're decaying. The factor for decay would be that 97.8%, which we need to convert obviously to a decimal number, 0.978. So that allows us now to come up with the equation that we're going to use to solve this. So our final amount would be 50% of the light. And our initial amount, or our starting value, is 100%. And we're going to decay by 0.978 raised to some exponent d. So the toughest part is obviously setting up these equations accurately. But they all sort of have that same format where you have a final amount on the left-hand side equaling an initial amount, or a starting value, and then either a growth or decay factor as the base of your power. And d will represent the number of meters. Okay? So to isolate d, we're going to divide both sides of the equation by 100 first of all to get rid of that factor. So you have 0.5 remaining now on the left. And you have a power all by itself, 0.978 to the exponent d. So again, this is where logs come into play. Because we're trying to solve for an exponent that contains a variable, if we take the log of both sides, that allows us to bring that exponent, the variable d, down in front. So when we take the logs of both sides, we can bring the d down in front and have the log of 0.978. From here, again, it's just like the last example. You're going to divide both sides of this equation by the log 0.978. So they cancel on the right-hand side and leave us d, which is what we're hoping for. And if you're good with your calculator here, you get approximately 31.15. Okay, so basically, we would round that to the nearest meter. Divers can descend about 31 meters before they would have to start using headlamps to see.